All right, let's talk about something that sounds like it's straight out of science fiction, zombie cells. But what if I told you they're not only real, but they might hold the secret to completely changing how we age? Not just living longer, but feeling younger for way longer. Okay, so think about this. All the big diseases we associate with getting older, heart disease, dementia, even nagging arthritis, we've always treated them as totally separate issues. But what if that's just wrong? What if they're all connected? What if they all share a single hidden root cause that kicks in as we age? Well, it turns out scientists are pretty sure they've found the culprit, and they've given it a pretty fitting name: zombie cells. Yep, these are the villains of our story. But don't worry, because where there's a villain, there's usually a hero, right? And in this case, it's a whole new class of drugs that are being developed to basically hunt these things down. But before we dive into the nitty-gritty science, let's get one thing straight. This is not about living forever. I mean, come on. The real goal here isn't just about adding more years to your life. That's your lifespan. It's about adding more life to your years. That's what we call health span, the time you spend healthy, active, and feeling good. The idea is to squeeze that period of being sick at the end of life into the shortest time possible. So what are these zombie cells really? Well, the fancy scientific name is senescent cells. See, in a healthy body, old or damaged cells have a built-in self-destruct button. They're supposed to get out of the way. But senescent cells, they're different. They stop dividing, which is good, but they just refuse to die. They literally just hang around, accumulating in your tissues like those party guests who just will not leave. And here's the twist. This whole process, this senescence, it isn't actually a bad thing to begin with. In fact, it's a vital defense mechanism. Think of it this way. If a cell gets damaged and is at risk of becoming cancerous, senescence is the emergency brake. It stops the cell from dividing and creating a tumor. So when we're young, these cells are actually our bodyguards. The trouble starts when these bodyguards get old and stick around for way too long. They go from protectors to troublemakers. As they pile up, they start pumping out this nasty cocktail of inflammatory chemicals. Scientists call it the SASP. It's basically like a constant low-level fire spreading through your tissues. This damages the healthy cells nearby, and get this, it can even convince them to become zombie cells too. This is that single root cause we mentioned, driving so many of those age-related diseases. So how in the world do we fight back against this? Well, this is where our hero re-enters the story: Senolytics. It's a totally new kind of drug, and it has one very specific job: find the zombie cells and give them that final push to self-destruct, cleaning up the neighborhood so healthy cells can thrive. The huge breakthrough came when researchers like Dr. James Kirkland over at the Mayo Clinic started asking a really smart question. They were like, wait a minute, if these zombie cells are spewing all this toxic gunk, why aren't they poisoning themselves? And what they found was fascinating. The cells have these incredibly powerful survival tricks, these defense shields they put up to protect themselves. And that's the key to how senolytics work. It's so clever. They don't go in with brute force. Instead, they act like a secret agent that briefly disables those defense shields, just for a moment. And with their defenses down, the zombie cells can't handle their own toxic mess, and they basically self-destruct. It's a really, really elegant approach. Now, this idea didn't just pop up out of nowhere. The groundwork for this has been building for decades. I mean, scientists first started talking about senescence way back in the 1960s. But things really started heating up in 2004 when they found a clear link between having fewer of these cells and a longer, healthier life in animals. And then, bam, 2015 was the real game changer. That's when the first study came out proving that a drug could actually clear out these cells and make old mice healthier. And when I say healthier, the results in these animal studies have been just wow. I mean, they took these old mice, gave them senolytics, and saw these incredible changes. Their hearts started working better, their fur grew back thicker and darker, their minds got sharper, they even started running on their exercise wheels again like they were young. It's pretty amazing stuff. And this isn't just about mice looking and acting younger. We can actually see the change happening deep down at the molecular level. There's this protein called P16, and it's basically a bright red flag that a cell has gone zombie. And as you can see from the data in these early studies, after the senolytic treatment, the levels of P16 just plummet. That's the proof right there. It shows a deep, fundamental reset is happening inside the body. So what are these magic bullets? Well, this part is pretty wild. One of the leading combos they're testing is a cancer drug called dasatinib mixed with quercetin, which is a natural compound you find in things like apples and onions. Yeah, seriously. Another big one is a natural compound called ficodin. These are the kinds of things that are leading the charge in human trials as we speak. And let's just bring it back home for a second, because this is so important. Again, this is not about chasing immortality. It's about completely changing the definition of getting old. The dream here is to make your 80s and 90s feel more like your 60s. To have more years where you're active, sharp, and just living your life to the fullest. Okay, but let's be real for a moment. We are not there yet. Not by a long shot. There are still some pretty big hurdles. For one, we need to know if these drugs are safe over the long term. Remember how these cells help with things like wound healing? What happens if you get rid of too many of them? And then there's the huge question of who gets access to this. Is this going to be something only the super rich can afford, or will it be for everyone? But even with all those questions, the potential here is just mind-blowing. This whole field of research is forcing us to imagine a totally different future. A future where getting older doesn't automatically mean getting sicker. So I guess the final question for you is this. If you could add 10, maybe 15 more healthy, vibrant years to your life, what would that future look like for you?